Good morning, friends. Welcome to Hydraulics and Hydraulic Machines class. In the previous class, we have discussed the first part of reciprocating pump, wherein we have successfully completed about what is a reciprocating pump, the classification of pumps, and then classification of reciprocating pumps, then components or parts of a reciprocating pump, then the working of a reciprocating pump, followed by derivation of the equation for the discharge, the work done, power, then coefficient of discharge, then slip, percentage of slip, what is a negative slip, and when negative slip occurs. After completing this theory part, we have taken up problems. So this is the part 1 of the reciprocating pumps. There is one more small thing in that part 1, and now in today's lecture, let us discuss on that small part. What is that? In today's class, our discussion will be on what is an indicator diagram, what it signifies, and how it helps us in reciprocating pump. First, indicator diagram. The word itself signifies that it is something indicating. Indicating what? Indicating the pressure head with respect to what? The stroke length. Finally, the diagram is a graph. A graph drawn between the stroke length on x-axis and pressure head on y-axis. If you draw it, that is what we call it as an indicator diagram. Now, based on whatever we have studied, let us go and represent all that in the indicator diagram. Let us straight away go into how to draw an indicator diagram. Really, when once you look at the indicator diagram, what do you understand? You yourself can say that. Let us go for it. So let us discuss about the indicator diagram. So what is an indicator diagram? It is a graph drawn between stroke length and pressure head. The stroke length is taken on x-axis. And then pressure head is taken as y-axis. So this diagram is represented for one revolution of crank. Always remember that indicator diagram represents for one revolution of crank. Of course, how many number of revolutions it makes, it only repeats the same process. So what is that? Let us straight away go into that. So if I take, this is the graph I am trying to put. Okay. So this x-axis, what I mentioned, stroke length. and y-axis what I mentioned actually, pressure head. You know that in the case of a reciprocating pump, the suction head is negative, that is less than atmospheric pressure. So first we should draw actually in this diagram where is that atmospheric pressure. So this represents this line, whatever I have drawn, represents actually, if you call this line to draw the graph, right? So if I call it as EF, this line represents the atmospheric pressure head. And you know, atmospheric pressure head is equal to 10.3 meters of water. So that is represented by this. And this actually represents, if you take this is what it represents here, it is absolute vacuum. So that means zero. Zero pressure head is represented here and it is 10.3 meters. Now the pump is started. So when theta is equal to 0, if I take the things, theta is equal to 0 to 180, you know that it is what we call it as suction stroke. So during suction stroke, so this is where theta is equal to 90, sorry, theta is equal to 0, and now during the suction stroke the pressure head is constant. See, during suction stroke the pressure head at every place is constant. So this is at theta is equal to 0 degrees and this is equal to theta is equal to 180 degrees, and at the center somewhere theta is equal to 90 degrees. Whatever is the angle during the entire suction stroke, the suction head means this head actually. If you take this head, this is what we call it as suction head. That's why we told suction head is negative head. It is less than atmospheric pressure. Right? And this is basically the suction head, HS. So during the entire suction stroke, the suction head is constant and it is less than atmospheric pressure, and basically it is equal to HS. Suppose if you want, what is the absolute pressure head? Absolute means actually this is the thing. So in that case, in terms, this is actually negative pressure head. Whereas if you want absolute pressure head, it is H atmosphere minus HS. H atmosphere minus HS represents this, I call it as AB. So this is HS and this represents H atmosphere minus HS. And what is this? This is the absolute pressure head during suction stroke. This is the negative pressure head. Right. Next, what happens? So after 180 again, 180 to 360. That 180 to 360 you can call it as same as 0 to 180. Anything is fine. So what will happen at that time actually? If you see at that time what will happen? Again, during delivery stroke, the pressure head is constant and it is above atmospheric pressure head. Again, here is equal to theta is equal to 0. This is theta is equal to 180. Right? This is the delivery stroke, and this head is represented by HD. This is represented by HD. So total head is HS plus HD. HD is above atmospheric pressure. HS is below atmospheric pressure. This is negative. This is positive. If you want absolute pressure head during suction stroke, it is H atmosphere plus HS. If you want actually what is the absolute pressure head? Absolute pressure head during delivery stroke is equal to H atmosphere plus HD. Delivery pressure head is, it is positive, it is HD. So total pressure head is equal to HS plus HD. So this is the. So now you tell me basically first thing is during suction stroke from theta to 0, the piston is moving basically in this direction. This is how the piston moves. Piston moves backwards and the water is being sucked. When the water is being sucked, the pressure head in this is suction pressure head. Suction pressure head means it is less than atmospheric pressure. That's why we have represented the line AB below basically the atmospheric pressure head. That is the first thing. Then during the delivery stroke, naturally it pushes the thing. So this is how the delivery stroke happens actually. When the delivery stroke means pushing, delivery is taking place. When delivery is taking place, the pressure again during the entire delivery stroke from theta to 0 to 180, again it is basically the same. So somewhere here again you can have theta is equal to 90. So this is what we call it as suction stroke. This is the delivery stroke. Right? AB represents suction stroke, CD represents delivery stroke, EF represents the atmospheric pressure head. This diagram, whatever you have represented, that the diagram which is called as, for example, this is the diagram which you are representing as A, B, C, D. And this is suction stroke, this is delivery stroke, and basically the somewhere here this is the atmospheric pressure, right? And this is below this is the suction head, and above this is delivery head. And this is suction stroke, delivery stroke. And to complete the diagram, then take x-axis, it is stroke length. I have taken stroke length exactly. This is equal to L, and then actually on this the pressure head. This is called as ideal indicator diagram. Ideal indicator diagram. Why ideal? Under ideal circumstances, this is the indicator diagram, right? So if some what is the real indicator diagram? If suppose the effects of the acceleration of the piston, if the effects of the friction in suction and delivery pipes, if you take that also into account, automatically the pressure changes in the suction and in the delivery. So those pressure changes also, if you reflect it, they are called as the real indicator diagrams. So till now we have not studied studied what is the effect of the acceleration of the piston on the pressure in the suction pipe and delivery pipe, and similarly what is the effect of friction actually on the pressure. Basically friction always leads to only the loss. Actually friction is a loss. The loss of pressure head in suction pipe and delivery pipe, how it is going to be, that is the next article. But why we have drawn this? So if you are able to draw the indicator diagram, what is the use for you? If you draw the indicator diagram, now you know already. Recollect actually once again what is the equation for work done basically per second by reciprocating pump. The equation you just recollect actually, it is equal to gamma into ALN by 60. ALN by 60 is nothing but the discharge into HS plus HD. This is what we have studied and we derived also. I make it actually in such a way, it is equal to gamma into A into N by 60 as 1 and L into HS plus HD. This is the work done. So if you see it, gamma is a constant, area of the cylinder constant, N is the speed is constant. All this is a constant. I am writing it as K into L into HS plus HD. Right? Then actually the work done per second is proportional to, I can write as L into HS plus HD. What is L? What is actually L into HS plus HD? Just look at the diagram. What is the L? Is the horizontal x-axis. HS plus HD is the y-axis. It is nothing but the area of the indicator diagram. Area of the indicator diagram. So this is the significance. The area of the indicator, that means the work done per second in case of reciprocating pump is proportional to area of indicator diagram. Or it is equal to gamma A n by 60 into area of indicator diagram. So this is for single acting reciprocating pump. In case of a double acting reciprocating pump, it is equal to again gamma an by 60 into 2 times area of indicator diagram. So we discussed about basically the indicator diagram first. And once the indicator diagram is what again? Please tell me what is indicator diagram? It is a graph drawn between the stroke length and the pressure head. The stroke length is on x-axis and pressure head is on y-axis. So if you draw it, actually the ideal indicator diagram is just nothing but a rectangle wherein the y-axis represents HS, HD and x-axis represents stroke length. In terms of the basically the HS is always less than atmospheric pressure, that you must represent, and HD is above it. So what finally indicator diagram indicates? The work done per second is proportional to the area of the indicator diagram. Our work done per second is equal to gamma an by 60 into area of indicator diagram. If it is double acting reciprocating pumps, just multiply it by 2. So this is completes to me the first part in toto. So you understand the whole thing as a bunch. Thank you so much. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.